challenge that our customers face is to try to reduce CO2 emissions from vehicles. And there are a number of ways of trying to do that, but maybe the nearest term method is to try to get people buying smaller car engines. But that means the engine has to work very, very well in order to be acceptable to the car buyer. So that's where we come in, trying to enable that engine to perform better by making the turbocharger around the engine function well, taking power out when it can, putting power in when it has to, so that the drive is pleasant and the driver gets what they want from the vehicle. We've developed some of the world's fastest accelerating and most compact electric machines, and these can be used to electrify a turbocharger. And that overcomes the classic problem with the turbocharger, which is turbo lag, the turbocharger not doing what you want when you want it. So by overcoming that, we've made the turbocharger a tool for reducing CO2 emissions from vehicles, making engines smaller and yet still providing the performance that car buyers expect. In order to produce electric turbochargers, we've also produced some very advanced motors and generators. We think some of the world's fastest and some of the world's most power dense and fastest accelerating. So the performance from these electric machines is required in order to get the behaviors that the user wants from the turbocharger, from the engine. So to make these systems work, we've had to develop every part of the electrification of the turbocharger ourselves, tailored for our application. And that's printing our own digital circuits to control the thing, through to writing our own software, through to integrating energy storage systems and moving fairly large amounts of power around the system. So we're sort of hybridizing the turbocharger. So we're not clever enough to do that ourselves. We're a very small team. So of course we've had to work very closely with anyone we can. Often that's universities. Universities have been fantastic, both at the early end. If we want to attach something mad to our system, they can tell us whether it's feasible. And then also at the later end, once we've blown something up or we've learned something interesting in one way or another, universities can help us interpret the results and incorporate changes into further iterations of our designs. We are developers who want to push the envelope of what our bits can do, and we have a lot of fun doing that in our lab, and I think do a lot of good work. But we always have to work with the supply chain and with our customers to make sure that what we're doing is relevant, that we're doing it in the right way, so that there's a commercial future for all this.